A pendulum swings down and collides with a block on the table. The block slides until the friction stops it. By measuring the pendulum heights and the block slide's distance, we can back calculate the friction coefficient between the block and the table.
The following diagrams are used to encapsulate and describe what is happening in the system during the problem. On the left, we can see two free body diagrams used to describe both the pendulum and the block at rest. In both, we can see a gravitational force and a reaction force affecting them, resulting in them being at rest. However, we can also see that the block is affected by a frictional force. On the top right, we can see what is occurring during the event. We can see that the pendulum swings towards the block before shortly about to make contact. When the pendulum makes contact with the block, it pushes the block to the right, and then the block generates a reaction force on the pendulum, swinging the pendulum back to the left. We can see that below that the pendulum's greatest potential energy is when it is at rest, hoisted up, whereas the pendulum's greatest kinetic energy is right before it makes contact with the block. The following two tables are used to show both the constants and the variables that will be present in this experiment. Some of these variables might have already been shown in previous diagrams.
It was calculated that the pendulum drops from 0.5 meters, giving 3.13 meters per second, rebounds from 18 centimeters at minus 1.88 meters per second. Conservation of momentum gives the block 8.35 meters per second. The back calculated mu k gets 0.3.
To determine the solution to the problem in Virtual Lab 1, we utilize the following methodology shown on screen. Starting from the top left, going to the bottom left, then to the top right, and then to the bottom right. The following was done. At first, we developed the initial equations and parameters and structure of the solution. This was then followed by determining what the pendulum's velocity was right before impact. Utilizing MATLAB, we utilized the MATLAB function shown third on the left to determine what the pendulum's velocity was immediately after impact. Using this, we were able then to determine what the block's velocity was immediately after impact, and as a result, determine what force the pendulum transferred over to the block. Utilizing kinematics, we were then able to determine the block's movements as it was sliding to the right from the impact, and as a result, determine what the dynamic coefficient for friction was from this measured data.
It was calculated that the pendulum drops from 0.5 meters, giving 3.13 meters per second, rebounds from 18 centimeters at minus 1.88 meters per second. Conservation of momentum gives the block 8.35 meters per second. The back calculated mu k gets 0.3.